Hello guys, in today's video we are going to learn about decision tree. Okay, first let's understand what is a decision tree. It's actually, in simple term, decision tree is a supervised machine learning algorithm. That means it's learned from already labeled data. We mainly use decision tree for a classification problems and also for a regression problem. So it can be predict, categorize, or it can be predict numerical values. The best way to imagine a decision tree, it's like a flowchart. It asks one question, then it based on the answer, it moves to the next step. Because of the flowchart style structure, decision tree are very easy to understand. You can clearly see how the model is taking decisions. Now let's talk about why we actually use decision tree. First reason, it is very simple and intuitive model. Even if you are new to machine learning, you can understand it easily. The decisions are made using clear rules, so we can see exactly why the model gives a particular output. And another important point is decision tree can handle both numerical and categorical data. It can directly work with the numbers and category labels without doing too much complex encoding. Also, there is no need for future scaling. We don't ever normalize or standardize the output data. That makes the pre-processing part much simpler. Because of all of the reason, decision tree are widely used in real-world applications. You all find them in healthcare, finance, marketing, and many decision support systems. Now let's look at the basic structure of the decision tree. Every decision tree starts with something called the root node. This is the very first point where the main decision is made. From the root node, we move to the decision node. These nodes apply conditions or rules to the data. Based on the condition, the data gets split into different parts. At the end, we have leaf nodes. Leaf nodes don't ask any more questions. They simply give the final output or prediction. The lines that connect everything are called branches. Each branch represents the results of a decision. Basically, it shows which path the model is taking. This diagram shows the basic structure of a decision tree. The process starts from the root node, then moves through internal nodes where decisions are made. Finally, it ends at the leaf node, which gives the final predictions or output. Now let's see how a decision tree actually works. Now this part is very important, so let's take it slowly and understand how a decision tree really works. First, the decision tree looks all the futures in the data set. For example, age, salary, marks, attendance, whatever inputs we have. The model's goal is very simple. It wants to answer questions that gives the clearest separation in the data. So from all the futures, it selected one best future. Best means the futures that separates the data is most clearly. To decide this, the model uses metrics like information gain or Gini index. We can think of this like asking which question reduces confusions the most. Next, split the data. Once the best feature is selected, the tree split the data based on a condition. For example, study hours greater than 5, so give yes or no. Based on the condition, the data is divided into smaller groups. And then repeating the process. Now here's the key idea. The same process is repeated again for each new group. Again it's look as a futures. Again it choose the best one. Again it splits the data. This is why it's called a tree, because it keeps growing branches by branches. When does the tree stop? A tree does not grow forever. It stops when the data becomes pure enough. Pure means all data points the node belongs to the same classes. Or sometimes we stop it using rules like maximum depth or minimum samples. At that point, the node becomes a leaf node and the final prediction is made. Now let's talk about splitting criteria. This part explains how the decision tree decide which questions to ask. First is the Gini index. Gini index tells how mixed the classes are in a node. If a node has mostly one class, the Gini value will be low, and that's good. So in simple terms, lower Gini means better split. Next, next is entropy. Entropy measures the amount of randomness or confusions in the data. If the data is very mixed, entropy is high. If the data is clean and clear, entropy is low. The goal is always to reduce entropy. From entropy, we calculate something called information gain. Information gain tells us how much the entropy reduces after a split. The feature that gives the highest information gain is chosen for a splitting. So overall these measures helps the tree choose the best possible split. Best split means data is separated more clearly and predictions become more accurately. Now let's understand decision tree with a simple example. Suppose our problem is to predict whether a student will pass or fail. So basically this is a classification problem. To make these predictions we need some information. Let's say we use study hours and attendance as features. These are the values the model will look at before making a decision. Now the decision tree starts asking questions. For example, it may first check study hours greater than some values or not. Based on the answer, it moves to the next condition, like attendance greater than a certain percentage. Once all conditions are checked, the tree reaches the leaf node. The leaf node gives the final results, either pass or fail. Now let's talk about advantages of decision tree. First advantage is it's very easy to visualize. Because it's look like a tree, we can easily see how decisions are being made. This makes the model simple to understand and explain even to non-technical people. Another important point is decision tree does not assume anything about the data. It does not accept the data to follow any specific distribution that makes it flexible for many types of problems. Decision trees are also fast to train. Even with a reasonable large dataset, the model can be trained quickly. Another useful advantage is that decision tree can handle missing values. They can still make decisions using different split strategies, even when some data is not available. Finally, let's look at the limitations and applications of decision tree. One common issue with decision tree is overfitting. If the tree grows too deep, it may start learning noise from the training data, then can reduce performance on new and unseen data. Decision trees are also sensitive to noise. Even small changes in the data can lead to completely different tree structure. Despite these limitations, decision trees are widely used in real-world applications. They are commonly used in medical diagnosis, financial credit scoring, and student performance prediction in education. One more important point, decision tree is the base model for random forest. Random forest multiple decision trees are combined to improve accuracy and reduce overfitting. So this gives a clear idea how decision tree works, where they are strong and where they are need improvement in the next video. Thank you all.